morning. Today we'll be talking about inverse trig, following up with what we talked about in class the other day. So we're going to look at quick graphs here of what we'll start with sine. So here is our sine graph. There's our sinusoidal axes, and the sine graph starts at 0, goes up to 1, down to -1. There's pi. And here is 2 pi. And of course this goes in the other direction as well. Down to 1, -1, up to 1, so on and so forth. I'm going to extend my axes over here. And there's our graph of the sine function. Here's -pi/2. Here's pi/2. Alright, so notice we're talking about inverse trig right here. This is theta and sine of theta. And inverse, if you remember from your algebra courses or earlier in math analysis and trig, inverses are when we switch x and y. Well, in order for an inverse to be a function, similarly to a function that has to pass a vertical line test, the inverse must pass a horizontal line test. Clearly, this does not pass a horizontal line test, right? I hit it once, twice, 3, 4 times sometimes. Okay? So we need to restrict this function so that when we do look at the inverse, it does pass the horizontal line test. And one of the ways to do that is to start here at -pi/2 and travel to +pi/2. So we're saying that the angle must be between -pi/2 and +pi/2. So that is going to be a restriction on the sine inverse function. Sorry, I'm just going to bring this screen back up here real quick. So sine inverse is restricted between -pi/2 and pi/2. Think about that in terms of the unit circle. Okay, there's our sine inverse restriction. In terms of the unit circle, this is saying that sine is restricted between -pi/2, right, if I go in the clockwise direction, and +pi/2 if I go in the counterclockwise direction. In other words, we're searching for answers in quadrants 1 and 4 only. In quadrant 1, sine of theta is positive. In quadrant 4, sine of theta is negative. And notice, this is important, we're going clockwise direction and counterclockwise. So we're talking -pi/2 to pi/2. The quickest way you can get there from 0 radians. Okay, either go clockwise or go counterclockwise. Get there as quick as you can. For example, if somebody tells you that the sine inverse is √3/2, okay, we are simply saying, well, at what angle does sine have a value of √3/2? Well, that occurs up here at pi/3. So our angle is pi/3. Likewise, if we're asked if the sine inverse, told the sine inverse is -√3/2, our angle is down here at -pi/3. Okay, we do not make one full rotation going through the unknown, right? If I go through this area here, quadrant 2, between pi/2 and pi, I am not passing the horizontal line test anymore. That is why our restriction is at -pi/2 to pi/2. Okay, cosine is very similar in this regard. So let's sketch our cosine graph. Here's our sinusoidal axes. Cosine starts at 1 and works its way down to -1 and back up, and of course it does this on both sides. Again, it clearly does not pass the horizontal line test. Let's find our values here. This is pi. This is pi/2. Now if I am restricting cosine so it does pass the horizontal line test, let's try the highlighter this time, see if that works any cleaner. I'm looking at this area right here, okay, between 0 and pi. So my cosine inverse is restricted between 0 and pi. Okay, in other words, think in terms of the unit circle, 0 to pi. I'm looking for solutions in quadrants 1 and 2, only again getting there as quickly as I possibly can. So if you're told the cosine inverse is negative 1/2, then my angle is going to be up here at 2 pi over 3. Okay, so again, notice this gives me a positive answer and this gives me a negative answer. The same is true for the other functions. We can derive them the same. We're not going to, though. Let's just quickly recap here. Sine inverse is restricted between the first and the fourth quadrant, so negative pi over 2 and pi over 2. Cosine inverse is restricted between the first and the second quadrants. The cosecant, which goes hand in hand with sine, is restricted the same way that sine is restricted because it's built off the sine graph. So also negative pi over 2 to pi over 2. The secant inverse has the same restrictions as cosine since it's built off of the cosine graph. Tangent, sine over cosine, right? Tangent inverse is sine inverse over cosine inverse, has the same restrictions as its numerator, which would be sine, negative pi over 2 to pi over 2. And cotangent inverse follows its numerator, which is cosine, so we go 0 to pi here. So one little edit to make here, apologize. The reciprocal functions and the ratio functions do not have the or equal to's here, right? They are strictly greater than or less than inequalities because if you're dividing by 0, that becomes an issue, of course. So apologize for that. We'll swap them out. Right, if you think about tangent at pi over 2, your sine divided by your cosine. Sine is 1, cosine 0, so it does not exist at those values. So the sine and the cosine have the or equal to's, and same logic is true for your secants and cosecants. And that is inverse trig. Remember, you're looking for one solution. In one of the two quadrants, you always include the first quadrant. Quadrant 1 is included for everything. And the second quadrant is the negative quadrant. So in other words, if you're talking sine, the negative quadrant would be the fourth. If you're talking cosine, the negative quadrant is the second. If you're talking tangent and cotangent, they follow their numerators' negative quadrant. So tangent follows sine's negative, that'd be the fourth. Cotangent follows cosine's negative, that would be the second. And secant and cosecant obviously follow their sine and cosine reciprocal functions for their positive and negative quadrants. And that's a quick recap for you on inverse trig. Have a good one.